Hi, it's Leah, and I'm explaining probability and doing some questions and probability in real life. So probability is really important because to know the chances of events happening in your life, probability will help you know all your outcomes. So mutually exclusive events are things that can happen at the same time. The theory of two events being mutually exclusive is if they cannot happen at the same time. So an example would be like when we flip a coin, a single outcome can result in both heads and tails. And so not mutually exclusive is when events have at least one outcome in common. So an example would be like rolling a die, the event of getting an odd face and the event of getting less than 4. So independent events are two events are independent if the incidence of one event does not affect the probability of the other event. And so dependent are two events are dependent when the outcome of the event influences the event first.
Okay, so the first question, we have Jules and Vicky. Jules' chance is 7 over 15, and Vicky's is 12 over 19. So each of them have a percentage of 0.46 repeating, and then Vicky has a chance of 0.63. So Vicky would have a better chance, so she should go first. Question 1. Number 2. So you got a game of Zim and a game of Zap. Okay, so this equals 3 to 1. But then you gotta go 1 over 3 plus 1 equals 1 over 4, which then equals 0.25. And Zap, you have 4 to 5, and then this will turn into 5 over 4 plus 5 equals 5 over 9, which equals a percentage of 0.5, which means that Sarah should choose BAP. This is supposed to be BAP. Choose BAP. We need to know what are the odds in favor of each option. Show your work. Okay, so the probability of option 1 would be 4 to 10. Then you go 4 over 10 minus 6 equals 4 to 2. Okay, then probability of option 2 is 7 to 9. Okay, So then you go 7 over 9 minus 7 equals 7 to 2. So these are the odds in favor. Okay. So now B is which option should the coach choose? So if you look at the probability of option 1, it is 4 to 10, which means it has a 0.4 chance. And then if you look at option 2, it has a 7 to 9, and that becomes a 0.7 repeating. So in general, the coach should probably choose option 2 is better. Because this is a higher number. Option number 4 is about 3 people running for president. So we have Jamal, and Jamal has a 40%. Okay, we have Rebecca, and she has a 35%. Then we have Henry, and he has a 25%. So question A is asking us, what are the odds in favor of each person winning? So Jamal would be 40 to 60, the rest of the percent, which also could equal 2 to 3. Rebecca's chances are 35, oops, sorry, that's messy, 35 to 65, which also could equal 7 to 13. And then we have Henry, and he could equal 25 to 75. So his odds couldn't be 1 to 3. Okay, so that is A. So then we'll erase A. Ooh. Okay, so now B is asking, what are the odds in favor of Rebecca winning because of all that? So B is, we can say Rebecca's equals 60 to 40, or 3 to 2. So the odds of Rebecca winning are 3 to 2. Okay, so this question is about freezing, drizzle, and the weather. So we're going to use the formula probability of Monday and Tuesday equals probability of Monday plus probability of Tuesday minus probability of Monday and Tuesday. So if we plug the numbers in, the probability of it freezing drizzle on Monday is 50%, plus the probability of Tuesday is 30%. And then you minus both of them is 10%. So then this equals, when you add these two together, equals 80% minus the 10% equals 70%. So the probability of it being freezing drizzle on Monday or Tuesday is 70% of that. See?
Okay, so here's my question. So a survey reported that 29% of families have an iPad, 35% of families have a TV, and 42% have no iPads or TVs in their homes. Suppose that a family home is selected at random. Determine the probability that there are TVs but no iPads in the home. Okay, so let's do the math. Okay, so this question is not mutually exclusive. So you use the formula, this one. And so I said that 29% have iPads, 35 have TVs, and 42 have neither. So then you got to get like the probability of iPads or TVs. So you do 100 minus 52, and that equals 58. Okay, so then you write down this formula. So probability of I or T equals the probability of iPads plus the probability of TVs minus the probability of iPads and TVs. Okay, so then you have to plug it into the formula. Okay, so once you plug it in, you put that 50 out of probability of iPads or TVs right here. So it goes 58% minus 29%, which is the probability of iPads, plus the probability of TVs, which is 35%, then minus the probability of iPads and TVs, because we don't know that yet. But then you move it over, and then you go 64 minus 58, because you go 29 plus 35 equals 64, and then you move this over, and that becomes negative 58. So then you go probability of iPads and TVs equals 6% because you do that math. And then you want to go TVs minus the probability of and, because you don't want TVs, which equals 29%. So the probability of TVs but no iPads is 29%.